Hello, beautiful people of the internets. Hello, humans, cyborgs, robots, and extraterrestrials. It is I, your friend, Dead Program from La Pipa here in beautiful northern Asturias in Spain. So I'm here with my robotic colleague Gopherbot, who is of course properly masked up because we are still in full pandemic. But in order to make a slightly clearer recording, briefly I will take off my mask until of course we have our special guests later in the show. All right, so last time we got together was last week, and we had a really fantastic experience together with our first live streaming software release of TinyGo. So really quite amazing process releasing a piece of software with so many contributors, so many new additions, over 100 commits, over 21 different contributors to just this release, not including, of course, all of the different people who contributed things besides just code, the really important things like documentation and testing and research and really all the other things that are necessary to create a project of such richness and depth as TinyGo. So anyway, it was a really great experience that we all had together. Hopefully you enjoyed it as much as I did. Took much of the rest of the weekend to finish all the different builds for Windows 10 and for the ARM builds that we still have to build manually for the Raspberry Pi native code versions. But we got all that stuff done, so it was pretty great. Then on to the next. We put in our new release tag, and we are now started on the next round of changes for what we anticipate will be a much quicker turnaround to the next version of TinyGo. We were basically waiting a little bit longer because of the release of Go 1.16. So now that that's out, it's a lot better for us to be able to proceed at our normal, more or less monthly release schedule. Typically, that's about the cadence that we've been following. In this case, it was a little different. So anyway, we have quite a lot of work that's been getting done by our wonderful contributors. And one of the things that, in particular, we have a lot of pull requests that are now still outstanding. And we haven't had a chance to get many of those reviewed and put in yet. So some of them are ready. Some of them are not ready. A bunch of them, actually, we've already merged. Let's take a look at and see what's actually gone on in TinyGo since last time. If we take a look here, we can see that we're 8 commits ahead of the release branch already. 8 commits. Wow, that's incredible. So what do we got in here? First of all, updating the TinyGo version tag to 0.18.0. And then we've got a few pull requests that got merged. One I forgot, I think, to add the Qt Pi and the Teensy 4.0 to the list of supported boards in our README and our docs. I know, we actually have 55 different software or boards and platforms that are currently supported by TinyGo. 55, wow. I thought it was 53. It was actually 55. I'm losing count. There's so many. But we have a few other commits of some interest. One of them in particular that I think is quite interesting is that we've removed support for Go 1.11 and 1.12. So we are trying to follow, generally speaking, the same kind of backward compatibility guarantees as the main Go implementation. We don't really view ourselves necessarily as separate from that. I mean, we're just part of Go, right? So the Go guarantee for backward compatibility is 2 versions from the current release backwards. So that means that the Go official support is, well, except for security patches. But so that means that the Go official compatibility support right now is Go version 1.16, 1.15, and 1.14. So here we are, and we were trying to support Go.11 and 1.12. We have had good reasons for trying to have that, partly because of the fact that the Ubuntu 16.04 long-term support version of Go is the 1.11 version. But because Go itself is so relatively straightforward to install, it doesn't have it has no external dependencies other than itself. It's a lot easier for people to be able to upgrade versions just by downloading right from the Go website. So as a result of that, we decided that it was a long time that we cut loose some of the older versions of Go that were proving to be kind of difficult for us to maintain compatibility for, especially with WebAssembly. WebAssembly, there's so many things happening in the world of WebAssembly that we just couldn't keep up with backward compatibility with incompatible builds of older Go's that barely have that support versus the latest builds where the support is getting more and more robust all the time. So we dropped that. So if you needed that, we're real sorry, but probably nobody needed it because nobody said anything in our GitHub issue that we created and publicized. So usually there's somebody if they really, really need it. No, everyone was like, get rid of it, drop it, kill it. All right. So in addition, though, we've got a couple of pull requests that got merged in to try to address one of the problems that I was looking into last time, right before the release, which was the Teensy 4.0 UART. So what's this all about? Let's take a quick look as a reminder, just because this is something that we kind of need to get done. So the Teensy 4.0 is a microcontroller from NXP of the Netherlands, very cool company, with powerful microcontrollers that are almost, if not as powerful as many full computers. So the Teensy 4.0 is not the latest, but a reasonably recent vintage. And we've had a couple of different pull requests outstanding to try to bring in full support for it. It has support, but there was a few things that were broken on the last release, specifically the UART, which is the Universal Receiver, or Universal Asynchronous Receiver and Transmitter. So that's how we can communicate with it. So what we're going to do here is, luckily Andrew has Ardnu. He's one of our more prolific contributors and has done really incredible amount of work lately. So this particular pull request needs to rebase against the latest dev branch. Yes, that's true. The tests are not going to pass. However, so we can't, I'm not sure if we can actually merge this as of yet. We'll see about that. But most importantly, we can test it because the code that's necessary to fix the problem that he is fixing in this very branch is, in fact, already merged into the TinyGo dev branch. So let's go ahead and let's pull down git rebase origin dev, my favorite command. So we can pull in the latest TinyGo code. Okay, we already have that. So let's run make. Make is going to actually do the build using the LLVM version that I've already installed, which is LLVM 11. That way we're using the latest and greatest LLVM. It's not the latest, but it's the latest released version, LLVM 11, that we're supporting. So that'll build, and then we can use that version in order to test out the code fixes. Basically, the fix that Andrew made, we just need to merge on top. Okay, so now it's done. So let's copy the file in, and then let's run TinyGo version. So TinyGo version should tell us, yes, we are on version 18 dev, and then the SHA of the build that we most recently used. But I'm still on Go 1.15 here with this particular version. I decided I wasn't going to try to do the big upgrade right before the stream today. Now maybe it would have been the whole stream, just me trying to get rid of all my older incompatible cache files and things like that. But anyway, So we've got that commit. So now what we want to do is we can just follow the command line instructions that are part of GitHub, right? So we're just going to check out branching from Andrew's feature branch into this development branch. The only thing is we probably already have a branch with that name. But let's go see what happens. I'm going to copy this. We'll paste it in. Probably going to see an error message. Yes. Why? Because I already have a branch with the same name from trying to test this out earlier. Not earlier today at an earlier time. So I can git branch -d to delete, and I can get rid of that branch, right? And now I'll check it out again. We pulled that in. And now I can git pull his branch on top of this branch that I have created to receive it. So let's just take a quick moment to appreciate what we just did. So the first thing I did was create a branch with this name off of my current development branch. So this branch right now will be exactly the same as the development branch. Then this next command of git pull, I'm going to pull down from his repository his branch of this name, and I'm going to superimpose it upon the branch of this new name that I made, which is off of my current development branch. That way I can test his latest changes, but on top of all the latest changes from the TinyGo repo itself that have been merged in up until this point. So very powerful aspect of Git. Git is very powerful, but it is not always obvious how to use it and what it's doing, even if the command seems simple, but what is it actually doing? So now I'm going to change a little bit from what GitHub recommended. I'm going to say git pull -- rebase from the origin in this case, which is his branch of or fork rather, of TinyGo, and then the branch, which is his feature branch, teensy40 uart 1649. So the reason I'm going to do a rebase is I would like to avoid a merge commit. I just want to get his changes only, but superimposed upon my development branch, and I don't want to have an extra commit saying there was a merge coming in from this. So we'll pull it in. It goes and it rewrites history, and now we can take a look and we can see here's his the most recent change that Ika had made, which is a change necessary to the inter-P part of the TinyGo compiler to support the difference in what the MMX, the chip from NXP requires. And then somewhere in here, down in the history, I assume it's down in here somewhere. Where is Andrew's commit? Because I'm not actually seeing it in here. I know it's in here, but the question is where. Maybe he rewrote history, and he, I'll tell you what we're going to do. We know the SHA of his commit, right, which is this 6B47. So this is the unique identifier for this particular commit. So let's get show and then that SHA. So yeah, that SHA is in here. I just couldn't find it in the list because, that list is kind of long. So many commits, so many contributions. It's so cool, but then we have to navigate this kind of maze of commits. But luckily we have this unique hash code, the SHA, and so we see, yes, that commit's in here. All right. So now we can actually go and test the thing that we wanted to test in the first place, which was basically to see, we can go back to see, the UARTs on the Teensy 4.0 did not appear to be working. And the way that we can test that is by running a program that is part of TinyGo that is called Serial. It's one of the examples that's part of TinyGo. So we can find it in here. In our examples, under source, there's a lot of files in here. It's true. There are a lot of files. So under TinyGo source, examples, there is a program called Serial. And this program is probably the most um, elementary kind of TinyGo program. Until you have a blank program and a serial program, it's pretty hard to do anything very useful with a new microcontroller board. So in fact, that's actually our biggest challenge generally is once we get those particular features working, then it's a lot easier for people to contribute, even ourselves, to add, those new additional capabilities that are on the chip itself. So package main, like we normally see, import the time package, which is just normal time package from then our main. We're going to forever, print line hello world, and then sleep for a second. So on the microcontroller, what this will do is this will output through the serial port, whether it's the UART or in some cases the USB CDC port, which lets you do serial communication over a USB port. But we don't have that implementation yet for the Teensy 4.0. So in order to check out the Teensy 4.0, what we need to have is we need to use our FTDI friend, which is a small board which lets you connect a USB port to the UART on a device such as a microcontroller, and then actually in the chip itself, it's doing the work to translate the UART signals to the USB CDC interface that then whatever computer you're going to plug into is going to support. So that's what we need to do in order to test out the Teensy. So if we go back to we pretty much, all we need to do this is we need to run TinyGo flash, and then our target is going to be the Teensy 4.0, and the code we're going to compile is examples serial. And in order to actually do this, we're going to, of course, need to plug in the cable. So I have the cable from my computer, and I can plug this in here. This is just a normal USB cable to plug into the Teensy's interface. And now I should be able to compile this program, and it should say something like, I need to push the button for the reset in order to actually flash this particular board. This board does not have an automatic reset built in, so I'm going to push the button. It resets it, and now we're running the program. So how do we know if it's working? So for that, we're going to need to plug in this other cable that I have here. Let's see if the cable will reach. Yeah. So this other cable here, I'm going to plug into the USB port. So on the Teensy, the UART is on pins 0 and 1, which may be a little hard to see with this cable there. But you can kind of see the pins 0 and 1. And then the other cable that's plugged in is the ground. So we have those three cables plugged into our FTDI friend. So if we just plug in that cable, and so in theory right now it should be actually already communicating. So in practice, I usually have noticed I have to restart the Teensy board. So let's go over to my serial interface. I use PCOM, which is a serial program, terminal program rather, that is part of many Linux distros. So we see that, yes, okay, it is ready. And here we see the serial port problem has been fixed. You can see Hello World is coming out of the Teensy. So good job, Andrew. Thank you very much. That fixed that problem. That's really good because now we can go on to some of the other pull requests that he has outstanding, which add support for the I2C interface and I think something else, the SPI interface possibly. Anyway, until we can actually see the data coming out, it's very hard for us to tell, if it's actually working or not, right? So the serial port is usually one of the best things to get working initially when you first are starting with a new board. So that's really, really cool. Now, I would like to merge this pull request, but I canceled it before when I was looking at it, mainly because I noticed that some of the tests had failed. And I think the reason for that was actually that some of the tests that we've removed from the latest versions of TinyGo, specifically the support for Go 1.11, and I showed you that Go 1.12, that we had actually dropped support earlier this week. So he hasn't had a chance to rebase those changes in yet. So once he does, then we can merge this pull request because, in fact, it fixes the problem. So I just want to make sure that it not only fixes the problem, but also doesn't introduce any unexpected problems with any of the other supported versions of TinyGo that are still on our active support list. So, so we're getting really close. I'm sure by the end of the weekend, this pull request will have merged. So that's totally cool. Yeah, the Teensy 4.0 is a very fast board. People use it for a lot of very interesting kind of high-end applications, audio, for example, digital audio. So hopefully we'll get some of that support added in some future releases. All right, so there was another pull request, actually, that I wanted to take a look at as well. So this pull request is one that's been coming in for a little while from our long-term contributor, Sago, from Japan. He's one of our more, Sago35, Takasago-san, is one of our more prolific contributors and also one of our more precise contributors. I have to say, I look at his contributions and I think my own contributions are not so well put together. Let's take a look at this just because it's so amazing. It's so beautiful that it's like if everything I did was so well presented and complete, I would be lucky. All right, but let's take a look. So what is the issue that he originally is trying to address? So the SPI support in TinyGo for the ATSAM D51, for example, which is the chip that is used in quite a few boards that are really popular right now. In particular, the boards that you've seen me pull out, most recently the Go badge, which hopefully we'll be together again in the not too distant future, and we'll all be hacking our Go badges at some awesome Gopher conference. So the Go badge is powered by an ATSAM D51 chip. So another board that is also powered by that same chip is the Pi Portal in all of its different variations. This one here is the Pi Portal Pint, which is the very tiny version. They have up to a very large, well, not large, but relatively large size screen. So those are just a couple of the boards that are supported. And both of these screens are connected to the microcontroller using a SPI interface. So what's SPI? What are spies? Mommy, I didn't know there were going to be such a thing as spies. So SPI is actually the serial peripheral interface. It's not quite what it sounds like. It's not as exciting as it sounds when you say, yes, I work with SPI. You know, like people are like, shouldn't you be not talking about that? Like, oh, no, I could talk about it all I want. No one knows what I'm saying. So SPI is the serial peripheral interface, and it is a high-speed interface that is generally used for communication with devices like screens as opposed to sensors. It does work with, there are some sensors, generally they're very high-speed ones. because that is one of the main differences between SPI and I2C or I2C, which is the other most common interface that you see with microcontrollers. So the SPI interface, it uses two different lines. One is going from the chip to the device, and the other one is coming back from the device to the chip. So this seems like it might be an excellent time to bring up the fact that this terminology of master and slave is actually something that many of us have worked very hard to get rid of most recently. So let's take a look at the open hardware. I should have probably prepared these things in advance, right? Open hardware renaming. Let's see if we can, yeah, here we go. So the Open Source Hardware Association is an open source hardware association loosely formed of those of us who are interested in keeping hardware and open source something that can be mentioned in the same sentence. And there's a lot of really fantastic companies and individuals that are involved in it. I'm just one of the secondary, tertiary. I'm just somebody in the room when important things are done sometimes. So one of the things that collectively was decided was a resolution to redefine the SPI signal names. So what this is about is a couple of different things. So first of all, words matter. They mean something. Otherwise, we couldn't use them to communicate information, concepts, ideas. And so the words that we choose have significance if, in fact, they're able to communicate information in its most complete sense. This was something that I learned, surprised me that I learned it a little bit later when I was studying mathematics. That when I first was a young child studying math, things sort of were explained to me because. So I wasn't really, I didn't quite get math to the same level. It wasn't until later that I was fortunate enough to have a teacher who spent some time to really try to explain ideas, not just memorize concepts, but really try to understand the ideas behind them, that the words that were used to describe certain ideas in mathematics were significant. For example, the associative property of mathematics, of addition and subtraction, is because numbers can be associated together, they can be grouped together. And I just, oh, wait, that actually makes sense. I can't believe it. Wait, math makes sense? I can learn math and apply it to a variety of different conceptual domains because I understand the ideas, because someone explained them to me, because the words that they chose actually matter to explain the ideas. So back to the SPI signal names. So a lot of these names are in there for no good reason because they don't even explain, in fact, an actual useful relationship between the particular two devices in question. So here we'll see this little diagram. We have the SPI controller and the SPI peripheral. So the SPI controller would be, for example, your microcontroller. And then the SPI peripheral would be, for example, your screen. This makes an incredible amount of sense. Master and slave, well, who's the master, who's the slave? Why is there a master and a slave? What if they switch places? You know, this idea just didn't really communicate anything useful, first of all. And more importantly, it also communicated something negative because there are many people to whom the nomenclature of master and slave are offensive. I personally find it offensive. So, and it doesn't communicate any useful information either. So do we not possess the power to refactor communication? We do. But it takes a group of people deciding, let's do it. And so this is where the Open Source Hardware Association's initiative to rename some of the terms used in the SPI interface. Okay, back to the pull request. So the SPI interface is incredibly useful because it's very high speed. It's pretty ubiquitous in that it's used, nearly every microcontroller has a hardware implementation of SPI, even if they do not have a hardware implementation of other interfaces like I2C, it's very typical that they will have one for the SPI interface because it's such a fundamental interface. So Takasago-san's pull request here is to deal with wanting to accelerate the performance, in particular of the ILI 9341 display, which is the one that is on a lot of these sort of small, cool little mini portal devices. One of them is this Adafruit Pi portal. One of them, I didn't bring it with me today. I ran out the door from my house where I forgot it, is the Wio terminal from Seed Studio, which is an extremely cool one. I'll bring that next time because that's totally worth playing with. So anyway, Takasago-san took a look at, with his logic analyzer, and took a look at the timings that were being used for the SPI communication and realized that there were these gigantic gaps that were taking place that resulted in a much slower communication than was necessary. And so discovered that by making some key changes here, that was able to, in fact, improve this performance substantially. Let's see if we can see any stats in here. So here's the most recent changes. So we can see this is the original code, and it's as it sends each one of these pulses with the bytes of the communication. And you can see over 420 nanoseconds between each of the bytes that is sent. So that's 420 nanoseconds extra added to the length of time, versus with the new transmit and receive routine that it now is only 84 nanoseconds approximately between the different communication bytes, because each one of these is actually a byte that's being sent between the chip and the peripheral. In this case, between the microcontroller, the AT-SAM-D51, and the display. And so here's some test code for just kind of proves it worked. So what we're going to do here is let's go back over to, and let's check out our dev branch. So we'll check out the dev branch, and then we will go and we will pull in the branch here from Sago 35, which sort of similar procedures. Now, one little difference here is that since Sago 35 is actually a member of the TinyGo organization directly, he created this particular branch right off of the TinyGo repo. So when I check it out, the source is the branch, and the destination is my local branch, as opposed to in the previous pull request where I actually had to pull it in from a different repository. So just a small but important difference there. So if I git fetch origin, and then I check out this branch, and then it says git merge dev, but I don't want to do that. So let's git fetch origin. So git fetch origin is going to pull in all of the different branches in the current repository. And you can see here the SAM-D5X SPI branch. So I'm going to check that out into a new branch with -B. So I've switched to that branch. And so now I want to merge in my dev branch, but what I really want to do is git rebase dev instead of git merge dev, because once again, I would like to not have a separate merge commit, but instead I would really prefer to just rewrite history and put it all in together. So let's go ahead and do that. And there's only a single commit, and it's pretty recently, so it shows up in our TIG UI, text user interface, and we can see the changes here that got made. All right, so how can we test them? Yes, so by the way, Chillance42 has a very appropriate comment from the stream chat. Master and slave convention specifies who is in control, but it doesn't say anything more beyond that. Well, yes, and elements of control have implications, of course, that are social as well as technological. So it's a little bit easier for us to say, the central, or in this case, the controller, as opposed to saying master and then, slave. Why slave? Why not just peripheral or device? So seems a little more correct. But yeah, good point. Good points. Let's refine our communication. Anyway, so to continue, let's basically take a look here and compile. If you remember the bouncing ball that we used, and I think that was in. But first let's do this. First we're going to make. Because we're going to make the latest TinyGo that's got the changes. I don't think we actually have to do that, only because since the changes that Sago35 made are changes that were made only to the machine package, that package is compiled at compile time. So it's not the compiler itself. It's actually the code that's used. Let's take a look at that, because that's actually very important and interesting idea. So in TinyGo, we have the compiler, right, which consists of a few different sub-packages that are in there. One of them is the interp package that we saw earlier that there were some changes made to. We have the loader, the builder. Basically, the compiler itself is separated into these different subsystems to make it a little easier to navigate how the compiler itself is written. But then we also have the machine package, and it's under source here. And so the machine package in TinyGo is our hardware abstraction layer. And so this is actually used when you run the compiler, not when you're building the compiler itself, but when you compile some TinyGo code to run against a particular target, then that's the time when this code comes into play. So I didn't actually need to rebuild the TinyGo compiler. That was probably just a force of habit. But I didn't actually need to do that in order to take advantage of this additional code to the machine package. But so if I want to run this, one way I can do so is if we go over to the drivers package. So in the drivers package, we have the example that's used. Actually, do we need to remove? I'm just wondering. So the drivers package may not actually test the thing that we want to test. And the reason for that is that the drivers package currently is using some special optimizations that were added for the ILI, whatever the model number is, ILI 9341 board. So there's actually a few special bits of code that were added in order to accelerate this by our same wonderful contributor. So I'm just wondering, is there also a pull request here to remove that and to only use the SPI implementation that is from the accelerated? Let's take a look, because I think there is. I believe that is the case. I'm trying to remember. Because otherwise, I cannot test that this is faster. I can test that it works, but I can't actually test that it's necessarily quicker, simply because I don't have such an easy way to do so without overriding the code that is in this TinyGo drivers repository, specifically code that was already written here to almost exactly do the same thing that's in this pull request, which is essentially, instead of writing a single byte at a time, one of the changes is that it writes multiple bytes at the same time. But come to think of it, it probably will not interfere. Let's take a look and see if we can get a sense of that. If these two pull requests, or if this pull request, if it's compatible, and also if it takes advantage of these accelerated capabilities. Because mostly it has to do with receiving and transmitting, which is in this function here. And if we take a look at that same function here of, so this is actually calling those same registers. So this is not a very good test for us as far as will it actually be faster, simply because it doesn't let us test the code that's part of this new pull request. So, what should we do about that? So, that is a very good question. Also, I'm wondering that I see that this is adding the SPY extra tag for the SAMD21. Shouldn't that also be for the SAMD51? So I'm kind of wondering about that as well. So I think I should ask that question possibly before we get too far into merging this particular pull request. So let's ask that question, because that kind of does seem important. Should this be ATSAM D51 in this PR? This is kind of important information. So, didn't actually look like I'm going to be able to test this quite so easily. We could possibly ask that question. No, I say add single comment. I have not found that the GitHub full review process works particularly well for me. It just basically it sort of creates a whole nother sub-thread of conversation that seems like it's very easily lost. I don't know. Maybe it's just me. But anyway, so the files changed here are to the ATSAM D51. And this definitely is ATSAM D21, so it seems like there's something wrong there. So also, I would like to be able to test it against the higher speed display, right? That's over here. So let's take a look and see if by some chance there's actually a branch that he was working on with an accelerated version of the same. So it looks like maybe no. Wait, yes. In fact, this is a pull request, or a branch rather, that uses only the communication that are specifically in this supported feature. So we can actually test this. This is good. Okay, we just need to pull in the branch that is in, let's see, what's the name of this branch? SPY bus SAM D51 or SAM D5X. Okay. All right, so let's actually give that a try, because I would like to be able to test it and see if it does in fact work. And also, we should be able to tell relatively quickly if it's in fact as fast as the current version, which, so if we go over to our micro, pretty sure last time when we were playing around with this stuff, we flashed, yes, in fact, that was one of the things we did right before the TinyGo release, was we flashed this very board with the bouncing ball. So this is the bouncing ball. Hopefully we can see that. It's a little bit of glare. Let's see if we can get that camera angle a little tiny bit better. Yeah, so we can see that. That's okay. That's decent. So that's the bouncing ball. So that's running on the ATSAM D51. And it's using kind of the custom code acceleration that was part of the driver's repo before Takasago-san's pull request that adds to it the necessary code so we don't have to put in that special purpose code, but in fact, everything is just faster. So let's try to flash that. So let's go back to, so we're in our driver's repo. Let's run TinyGo version so we can take a look and see that, yes, we are running that latest build. Okay, very good. So we should be able to do TinyGo flash, and then target would be the Pi portal. And then the example that we want to put on it is the ILI 9341. Oh, but wait, first we have to check out the branch. So let's do a git fetch. Okay, so it looks like that branch was already in there. So if we do git checkout, what was the name of it again? Spybus something? Spybus Sam 5X. Is that the name of the branch there? Looks like spy. Drivers. Well, let's make sure that's the correct one. It looks like they're the same. One easy way to tell is to use the branches view here. Well, easy way to tell? I don't know. Let's find out. So if we take a look at some of these active branches, I don't see it listed. Maybe it's listed under the stale branches. It has been a little while. So it looks like this one is a little further ahead than the other one. It's got another commit in there. So yeah, let's take this one. Spybus Sam 5X drivers. So that's the branch we want to check out. And then let's git pull, rebase, origin, and that branch so that we pull in any of the latest changes. Okay, we got them. So then let's also git rebase our dev branch. Okay, so now we got everything. So this should have it all. And we can see in here, yes, it looks like we've got it. Good sign. All right, so now let's go back to actually trying to flash this code, which was tinygo flash target PyPortal, and then examples, the ILI 91, and then that's the one that's called PyPortal Boing. So let's just real quick, so we have a point of reference, go back to the micro camera, so we can see that it's sort of, this is about the speed. Bounce, bounce, bounce. Okay, so now let's go and flash it. Hopefully no errors. Okay, it's flashing the code. And we can see that, in fact, it is now running at approximately that same frame rate, but using this new code. That's not very scientific, is it? Guess what? We can do a tiny bit better. So it turns out that we should be able to go over to our COM port, and we should be able to see some, wrong serial port. So we need to unplug, let's see, one of these. It's ACM 0. And I don't see anything. I'm not seeing any data coming from the serial port from this. Maybe we need to restart it. So I'm going to unplug and replug. I thought this output the frame rate. Maybe not. Maybe we should look at the code and see what it actually does before we make grandiose predictions of its ability to log this information. I thought it did somewhere. Maybe that was a special example that was doing that. Let's see here. So it's under the ILI 9341, and that's the driver itself. We want to find the example for it. So the ILI 9341 example is here. It's under PyPortal Boing. And we look at the main. And yeah, so this is all the bouncing code, drawing the background, but no, it's not actually outputting. I think that's a special version that I have in one of my demos that I showed. So actually I got to take a look into that and see. Probably we could bring that back. I would guess that that was one from FOSDEM 2020. So I tend to keep all of my demos in various repos. let's see, where might this one be? Actually, I probably have it locally, just because I have everything locally, naturally. So if we go over to under my presentations for FOSDEM 2020, under the demos, under, let's see, balloon maybe? Ball. Yeah, that's it. Under ball, graphics. So let's see what's in there. That's something else. No. Ah, here we go. So I like Nano. It's the editor of the future. The editor for people who can't figure out how to get out of Vim and they're stuck in there forever. They have to get a new computer because of it. Am I kidding? I don't know. So this is actually using the parallel interface, not even the SPI interface. So that's maybe not the best example either. All right, so never mind that. So, all right, forget that example. That was a good idea, but let's go back to the other one, which is the one that's built into the driver's repo. And if we take a look at that, right, we can see for the PyPortal, it's actually using the parallel interface. So this is not a good test at all. It's the WIO terminal that uses the SPI interface to this screen. So this test has been invalid the entire time. Cool. Let's go and take a look at a different device that has the right kind of display. I think it's one of these. No, that's I2C version. Oh, these are the examples anyway. I think the SPI interface is the interface that is in use on the Pi badge. Let's take a look. I have that code located in a different repository, which was called, what was it called? Well, actually, there is an example in here that should still tell us. So the Pi badge from Adafruit is a very cool badge. You've seen me play with it. So this particular badge, it's got the, which is the display it's using? Let me see here. I've done this before, but I forgot where. Let's see. So the Pi badge is one that has got yes, this is the AMG 88 51, I think. Anyway, this should work reasonably well to actually show two different peripherals at once operating. One of them is going to be the SPI interface with the display, and then the other one is going to be the camera. Wait, I don't have this camera. This is a really cool camera that I don't actually possess. This is a forward-looking infrared camera that was added to this repo by our awesome contributor Conejo Ninja. And I think he either won it in a contest, or maybe he bought so much equipment from some company that they sent it to him, or both. Maybe that was the equipment that he bought. Okay, so I can't really test that. That's unfortunate. But I can maybe modify that other code to test the thing that we want to test. That would be a way to do it. Let's see if we can delve into that a little tiny bit. So this is the code we're going to need for the Pi badge right here. And if we go over to, let's see, the easiest way to do this will probably be if we go back to the window that I was opening before. which was going to be another terminal session inside of tmux, whose purpose was going to be to bring up the code for the demonstration that used some type of display that involved the badge. So let's use Go 1.15, and then let's change directories to, let's say, presso fosdem 2020, which was the previous year's fosdem. And somewhere in here, I have a demo that does use that exact screen. It's probably my badge. Yeah, I have the flight badge program. So flight badge was the thing I used to fly drones before I made the most recent flight control stick. And it's one that actually is designed to just use a serial interface to communicate with a separate Go program that's running on my laptop, and then use that for the Wi-Fi interface to communicate with the Tello drone. So yeah, kind of complicated. Got a few extra pieces moving. The point is we just want to test to see if this is even able to run. And if so, if the screen is faster, right? But this is maybe, again, also kind of a complicated demo. What happened to the ball? Let's go look at the ball. So the ball is using that ILI display, but in theory, we should be able to use most of the same interfaces because they support an interface in TinyGo that is known as displayer. So the displayer interface is part of the driver's package, and it's a relatively straightforward interface. It only has 3 functions that are exposed. One is size, so that returns the current size of the display. One is set pixel, which modifies the internal buffer. Got a little typo there. Got to fix that. And then one is actually sending that display buffer to the screen. So it's kind of a simplified way to communicate with the display that is device independent, but that may or may not take advantage of all of the fastest communication. Right? So let's go take a look and see what the implementation for the HD 44780 looks like. Right? Because that was the one that we were going to look at. No, that's a parallel interface. Sorry. Which is the one that's on the Pi portal? Or the Pi badge? The Pi badge has the... the Pi badge also has an ILI 9341. And that's a parallel interface. So that was why we said we didn't... Oh, no, that was the ball. The badge, here we go. The badge is using the ST7735. Okay. So let's go and look at those demos to see what we've got. So under examples... By the way, let's close a few of these up because we've got too many things open. So under examples, for the SS7735, so we have this demo which basically just, as quickly as it can, fills the screen display, and then that's it. It's not very exciting. But at least it tells us that this is in fact working. However, I think we maybe need to change to the other SPI interface, because if we take a look at the code we were just seeing for the Pi badge, we see that in fact it's using SPI1. So in order for us to display on the Pi badge, we're going to need to use SPI1 and not SPI0, which is what this demo here was doing. Right? We see that this was using SPI0. So in order to test this, we're going to need to use SPI1. Okay? And same thing here, that we're going to need to specify what are the ports that we're using for the display. So let's change this to 1. And then what are the pins? We have the reset pin. Let's see if... no, I must have an example that shows the Pi badge with... Oh, yeah. There is the really cool repo that was created by... that we used for our actual badges at the different conferences. Let's see if we can find that. I believe it's called... it's under the hybrid group repos... under the hybrid group organization on GitHub. And it's called something to do with badge, I believe. Go badge? No. Maybe it's under my personal repos. Let's see if we can figure this out here. I think it's called Go badge. Might not be. Might have a different name. I have a lot of repos. You may have noticed. I'm having trouble remembering the name of this repository. Well, when in doubt, go back to your list of directories. So, under my development repositories, I have many repos, and one of them is called Go badge. So that's got something in there. Okay, that's a good sign. Let's go and take a look and see what's in that repo. By the way, let's go. It's probably pretty old, but it might still work. So let's see. First of all, it is set up for the correct Python Pi badge. We know that because here we see the right SPI configuration. It's also using a couple of the other features in there. This is actually a really cool piece of software that Conejo Ninja, Daniel Esteban, had created sort of as a showcase of the kind of things that you could do with the Pi badge and with TinyGo. So I haven't tried to compile this in a really long time. It'll be very interesting to see if it still works. I guess we'll find out. So the first thing to do, so do we have the right version of Go? Okay, and do we have the right version of TinyGo? We do. Okay, so now we should be able to just TinyGo flash, and then target is the Pi badge, and the code we want to flash is the current directory. So let's see if it's even able to compile it. I probably want to unplug the Pi portal. So it looks like it's compiling. Oh, unable to locate the serial port. Excellent. That's a good sign. It means that it compiled the code. Doesn't mean it's going to work, but it did compile it. So let's plug in the board itself. I haven't actually tried to compile this in many months because it's been that long since any of us went to a real live conference. It's kind of sad. So, okay, let's see if what happens. It's flashing. And it goes into the flashing mode, downloads the latest code, and what happens? So far, nothing. That's interesting. I think there was a bug somewhere, but that it may have been fixed in a release of this code that maybe I don't have. So when in doubt, we can go over to Conejo Ninja's repository. Daniel Esteban, my colleague, hanging out with his baby girl. They're down in Murcia. So somewhere on here is the badge. listed under these many repositories of which he is doing continuous work on so many cool things. Ah, yes, Go badge. Here we go. So let's go and pull down this repo, because anything that's last commit says fixes almost is for sure to work, right? Yeah, almost for sure. So the easiest way to do this is going to be actually if we just pull his repo down locally. So let's go back to my Go badge repo and let's change directories. Let's move my Go badge into Ron Go badge, and we have to move recursive, otherwise it's just not going to have it. I think it's R. No? Wait. Isn't it? Oh, maybe we don't have to move recursive. No, we don't have to move recursive. We just moved it. It's okay. It doesn't mind. So then we're going to just git clone his repo, Go badge. And let's change directories into it. And almost for sure this is going to work a lot better. How do I know? Just because I have great confidence in my... sorry, no can do. Let's take a look. Ah, yes. The reason for that is that we are going to need to make a small change. So, okay. Since the time that this repository was worked on, there have actually been some fairly important changes. Well, hold on here. How come we're not seeing a proper tree view? There we go. That's a bit more like it. All right. So since the time when this code was actually created, some pretty substantial work has been done on moving a couple of the repos over. So the most important part is that actually these fonts are now part of a separate repository that's actually part of the actual part of the TinyGo organization, right? So in order to incorporate his repository, my easiest thing to do is probably going to be to either overwrite that part of it, or that's one option, or I can just make the attempt here to overwrite, this directory has got this path, but now that Go modules are in place, we can't just simply load repositories. One, just simply not just load repositories from wherever you want, right? So the easiest thing for us right now is probably just to create a mod file, right? So if we say go mod init, and we're going to call it Conejo, github.com/Conejo Ninja /Go badge. So that's the package name. So now we've got a package. So now if we try to do the same thing I did before, it says, oh, I got to download all those modules because TinyGo has Go module support. So it's going to go and pull down all of these different modules, which is going to take a while. But not that long. It's already flashing the board. And let's see if something better happens this time. Let's see. So far, and the answer is no, it still doesn't work. Wait, yes! I was just impatient. Oh yeah, look. We actually see the menu on the board. This is incredible. This is actually using the latest TinyGo with a repository that hasn't been updated in some months. So, cool. All right, so let's take a look at some of the features on the Go badge. So we have the badge feature, which, what does that actually do? I think that's maybe what we're doing here. Ah, yes, this badge runs TinyGo. We were out there pimping. We were at, I think the first conference where I was bringing this badge with me was maybe at the very last OSCON in Portland, Oregon, conference that's no longer in existence. So we can see, also we can see down here at the bottom, let's see if we can get the right angle. So down here at the bottom right, when it pops up, you'll see the really cool, I can't quite see them. Those are the Gopher fonts that were created by Jana Rackel, who is an amazing open source contributor, human being, genius, and general artistic person. She decided that it would be very cool to have all of the little Gopher icons in the form of a font, and so she created a font. We saw that. I think Danielle saw it and just thought, okay, this needs to be a TinyGo font. Turned it into a tiny font, and here we are. So kind of cool. So let's look at a couple of the other features on the badge. Now, it would not be any sort of decent, respectable badge without a built-in Snake game. Yes, Snake. It is the game. Snake. You know, like the game that you played once upon a time on your Nokia phone. Yes, so this is all written in TinyGo. As you can tell, it's been a while since I played Snake, because I lost my touch. Oh, I see why, because I'm looking at the monitor with the latency. Yeah, that's my excuse. Uh-huh. It's not just because, you know, I'm not good at Snake. Oh, there's one. There's another. Okay. Am I a snake shark? You decide. Snake, part shark, all open source. So this is kind of cool. So yeah, and it's looking really smooth. And also, more importantly, it's actually using the accelerated SPI code for the display, and everything is still working, and actually it's quite smooth. So that is really cool. Amazing work on the part of two of our important, everyone's important, but two of our highly contributory contributors. I mean, they've done incredible amount of effort, both of these people, so that is so cool. Let's see if there's any other demos on here. Oh yeah, one that is also kind of neat, rainbow LEDs. So this is using the NeoPixel LEDs that are built into the Pi badge. So these are actually controlled using a kind of specialized one-wire protocol that's very specific to the WS2812 lighting. And so, yeah, we have support for that in TinyGo and also on the Pi badge. So, totally cool. It's all actually working. And so I think the pull request is ready to merge. I mean, it actually is doing, it is in fact doing everything that it was promised to do, which is it improves speed and it's still compatible with everything else. Except, of course, there's this one little thing. So I'm wondering why that's in there. So this is basically saying in the build tags for the machine package, it's saying to only build when it's not bare metal and then when it's one of these other tags. So that means it probably shouldn't have actually worked, right? So why did that work? That is a good question. Let's take a look and see before we are committed to committing and make sure that we actually know what we're doing here. Just because once the code is in the development branch, I feel a certain personal responsibility to making sure that it's care and feeding. I was trying to come up with, what was the term? Caretaker? Warden? Like a game warden? No, that's a little more... game warden involves like too much of a superior relationship or some sort. You know, caretaker, that seems appropriate. It's got the right kind of reverence. You know, docent, something where you are helping to take care of something that other people will use and enjoy and need. Anyway, what were we going to do? We were going to take a look at this pull request and see why is it that we've got this bit of code in there that seems suspicious? So if we go back to TinyGo and we go down into our machine package, we see that we have in here this spy file. And so the spy file here is basically got this build tag, and it's saying that you only want to include this particular file if it's not bare metal, or it's ATSAM-D21, or it's one of these things, which are the STM32s, or it's the FE310, which is one of the RISC-V processors, or the K210, which is also one, or the AT-Mega. So I'm just kind of wondering, like, how did that work? Seems like something is not right. So before I actually merge this, I'd like to get some confirmation about, it seems like that shouldn't even have worked. Right? So let's change, but there is also another possibility. So let's go back to the Pi badge. We were just looking at it a minute ago. I have it. Pi badge Adafruit. Did I make it up that the Pi badge is using the ATSAM-D51? No, I did not. It is, in fact. Okay. So, once again, how did this actually work? I want to try changing this to what? Whoops. Let's try changing this to ATSAM-D51 and see what happens. Shouldn't have any difference at all, right? Let's go and look and say git status, take a quick look, git diff. We can see that yes, indeed, we did change the build tag that we're using for that particular processor. Okay, so that should be good. And then let's just go take a look and see if we can actually compile that code, which was over here, I think 9, Go badge. So let's change that to Go badge. And let's just make sure that it, okay. So take a look and you see this is the failure that we were expecting. All right. So what does this tell me? It tells me that maybe there's something wrong with the definition of the Pi badge in the TinyGo files. Let's go take a look at that very quickly, because then I want to shift gears to something completely different. But let's finish this first before we move on. So if we look at the board definition for the Pi board, or Pi badge, I should say, we see that the Pi badge is the build tag that's used for it. And if we go and we take a look at the target files, the target files are what's actually used by TinyGo when at compile time. And if we go and we take a look down here at the Pi badge, and we see that it does inherit the right tag from the ATSAM-D51, which if we go and we look at the target file in JSON for that, the 19A, and we see that this is also expecting the ATSAM-D51, right? So, something is not quite right there, is it? Because that should not have worked. So I'm not going to merge it yet because I am confused. And when I am confused, it is usually best to wait. One cannot be in too much of a hurry to merge any given pull request. But what this, again, this build tag should be saying is only include it if it's not bare metal or it's the ATSAM-D21. And now when I try to rebuild this, you'll see that reverting that change, now it's working again. So something is not quite right. I'm not sure exactly what it is, but I will look into that because I would like to merge that pull request because it looks really good. All right. So it gets very sad and lonely in these times of COVID. And I thought it'd be really cool. One of my friends and colleagues who hangs out here at La Pipa, which is where our streaming studio is Lorenzo Amante. So,
Ron. How are
hey,
you?
so I'm going to put on my mask because we all have to be masked up here in the times of COVID. So he was hanging out here. He's actually a hardware hacker as well, and has been doing a bunch of really cool things with MicroPython. So naturally, we really like MicroPython, but also we would like to get people to use TinyGo. So he was asking me some questions about, why should you use TinyGo? What were the differences? So, give a big hello, shout out to my main man, Lorenzo.
Hello, everyone. Nice to meet you. So, yeah, actually, I am on the user side. I'm not really a developer, but I found this very interesting. So I was wondering, well, I mean, what's the difference is here with TinyGo? I didn't touch it.
Hey, why don't we switch? Because I'm much louder than you are.
No, okay,
And you can be closer to the microphone.
it's fine. So I was wondering, I mean, what should I do, first of all, if I would like to start with TinyGo? I don't know if I showed you earlier, but I have some ESP32 controller boards that I use.
He brought some toys.
Yeah.
Okay, that means we're going to have to take a look at them. Okay, pull one.
Do you mind?
Oh, please pull it out. Don't tell us you've got it unless you're willing to pull out your toys.
Okay, this is one of the things I think.
Here, let's look at under the micro camera here. So what is this? This looks like some kind of ESP32 board.
Yeah, I also forgot what's inside in there. So probably, if we connect it maybe and connect it via serial, we should probably see the MicroPython interpreter running. Maybe. But I could be wrong.
Well, that's worth a try. Let's find out. So yeah, this is a cool little board. So what kind of wireless is on this? Is this a LoRaWAN
It's
antenna?
a LoRaWAN. It's a LoRaWAN. You also have Wi-Fi and Bluetooth. I think it got an accelerometer, temperature, and I don't know if there is something
Wow.
else.
So it's got a lot of got a lot of things.
I hope it switches on.
I guess we'll find out if it boots.
It, hold on. This is very weak. No? Okay, it's dead.
Yep.
Maybe I have another one, but there should be...
I see some lights.
Let's try this one.
Didn't let out the magic smoke.
This one has... no, this is a brand new one, so it's just plugged in, but it does not...
Have any software?
Yeah. Oh, probably is the...
But so it's an ESP32 or an
ESP32, yes.
Yes. So that sounds interesting. So let's see. So it's an ESP32, is it? So basically, one of the things that... So let's see if we can flash it with TinyGo and make it blink. I mean, what could go wrong, right?
Yeah.
So we can...
I flashed it many times, and I mean, so...
Cool. So TinyGo already has the built-in support for the Extensa ESP32. It doesn't have a lot of support, but it does have some. So we should be able to just say TinyGo flash target, and then I believe the targets, actually, one way to find this out nowadays is to say TinyGo, I think it's info. Let's see. Oh, if I spelled it right, that would help. TinyGo list.
Let me see.
No, that's not it. I thought it was TinyGo info. TinyGo list. No, that tells us, let's see, what was it? There is a way to get this information, but I can't remember what it is right this second. I thought it was TinyGo info targets, or something like that. TinyGo targets? I know there's a way to do this, but I can't remember what it is right now. Let's go take a look. Well, we don't have to do that, because the whole point was just for us to be able to flash this board. So on the TinyGo website, we have a few different microcontrollers that are already currently listed for the ESP32. I think one of them is called the Mini 32, and the other one is the core board. They're pretty much the same. So we should be able to do this, but one thing that is a little different is we do have to specify the port to be the TTY USB 0 because that's usually how it shows up. And we could tell that just by looking for LSDev right now. And let's see, do we even have that board appearing?
Yeah, it
Oh, wait,
looks like it's powered on, but
I'm not seeing the USB port for it showing up. And this is how you normally flash it, it's just by the USB?
yes.
Do we have to turn it on or off to a different state to do that?
No, this should be on already because it is the broken switch, but I know it was working. Or otherwise, we can try again with this one. It should be working.
Just because usually the USB port that's on the ESP32 will show up as USB 0, generally. Let's make sure we are plugged in, yes, okay. Seems like should be working.
Because we have also a new one, so
just when in doubt, keep pulling out more boards. You know, this gets kind of, that's just why these hobbies are very expensive. Let's
yeah, it's not for the
it did
single
boot
board,
up,
but for the quantity you have to buy.
Yeah, exactly. The amount of dead hardware that I have.
Now I know that if you don't plug in the antenna, yeah, it will burn the transceiver here. That should be the right one.
That's off, that's on.
Well,
I don't see it. Usually it pops up under
USB something.
Yeah, it'll be on Linux. It'll be USB 0 typically. That's what we usually see.
Yeah, let me see because I got glasses.
Because I have another. Let's just make sure that when in doubt, sanity check or insanity check or some other check. In one of my bags I have a ESP32. Well, I did. I might have left it. I had too many boards and not enough time, so I may not even have brought it with me today. Yeah, no, I didn't bring that board, of course. But, I mean, it is doing something.
Yeah, it's powered on. On the display, do not expect anything, but there, yes, you should see USB appearing. No, we cannot plug it directly because on and off.
Just because usually what happens is in this enormously large list of dev ports, it'll pop up under USB or /dev/TTY USB 0. And there it is, TTY USB 0.
Oh, okay.
Okay. All right, so we should be able to just flash it like this with the blinky sketch. And this is what we're doing, by the way. We're just going to flash it with the blinky sketch, hopefully.
Here, maybe it should blink.
We'll go back to the camera, and we'll see if something happens, hopefully. So it's
There is some blinking activity.
so it's erasing the flash. It's setting our flash params,
Can
hopefully.
you see that one? Maybe
It's trying really hard. Let's find out. Hopefully we aren't breaking it. Oh, fatal error occurred. Wah. Let's try it again.
doesn't like it.
Okay, try again. Flash params. Set to chip is unknown, ESP32. Could not detect flash size. Do you have to use some special parameters when you use the ESP tool?
Baud rate, what did you use to flash it?
So if we go and we take a look at, normally it will automatically choose the right settings based on the defaults, which are, let's take a look and see what TinyGo does for its defaults for that board. So we go to the TinyGo target
Let me see if I have something on the...
for the ESP32, which core board, It uses the ESP32 defaults, and it looks like it does not specify a particular baud rate. It specifies the port, write flash, the bin file, and then if you take a look at the,
Hold on.
oh yes,
Yeah, because
pull out the glasses. I know this is what
ESP
happens.
tool, yes, that's the one. Right flag. Yes, 1000. It's a right also address, and maybe we can remove something. And I don't remember what is for ESP tool. I wasn't using all that configuration. Probably that was the chips and
Trip and
port.
And write flash, and then get rid of these other params, maybe? To try that out?
I don't remember, to be honest with you.
Well, let's take a look at the docs for ES. Well, actually, I already have ESP tool. So TinyGo currently requires that you install the ESP tool in order to flash these chips because
Yes.
we don't yet have pure Go support. We will do that.
I use yeah, the ESP tool was also. I was using a different serial connector, but to flash, I used to R something.
So maybe this man page for it might rekindle your memory about which one of these params might work with your special board.
Let's see.
Maybe we need to try a different baud rate?
Right flash? No.
What was the exact error? Let's just scroll back real quick, and I don't remember actually the error that we had now. Oh. It's not cooperating. Something's wrong with my normal key combos here. I wonder what happened in this. Maybe, that's kind of weird. Well, anyway, let's just flash it again to...
Let me see if I have some notes in my laptop. Maybe some history.
So it's trying to erase the flash, sets the flash params, and then doesn't get any further. So it could not auto-detect flash size, and it timed out waiting for packet header. It seems like I've seen this error before.
We should go on the MicroPython.
Are we sure that it's the right port? So it does list it. Yeah, it's under USB 0. Let's see what happens when we connect to USB 0 just as a serial port. So we were able to connect to it, but nothing's actually happening. So usually that means it's ready to flash. I think if I disconnect it, unfortunately it's going to drop my Picocom connection, so I won't be able to see the boot up process. But that usually is something that can tell you something with these ESP32 boards, is when they first boot up, they usually spit out some information. So in this case, yeah, we can see that it's running, it looks like it's running the,
Yes, okay.
it looks like this particular board is maybe not flashed yet. Is that possible?
Sorry? Yeah, we can change it now.
Well, I'm seeing, isn't this the default firmware?
I have this is basically the configuration. I guess first we need to erase, and maybe then you can use the same. Okay, baud rate, for example, here it's...
Like, normally that's automatically set, isn't it? So let's go take a look here.
I will give you another board.
Well, this board looks like it's flashed with the default ESP-AT firmware. Does that,
It's
is that
possible. It's
seem...
well, no. This one really should be already flashed with MicroPython at least once. So if you want the new one, yeah, should have the default. If you would like,
Does
you
the
can.
power switch matter? Or is there a jumper that we need
No,
to
it's just
set?
for the battery, honestly. If you connect it to USB, it should work anyway.
Is there a jumper that we need to set to put it in the
No,
bootloader mode?
no, nothing like that.
Okay. Well, let's give this one a try. This one's
This is
brand
new.
new.
This is brand new.
This one's brand new.
So,
We're the first.
no,
We're the first.
yeah, and this is as the default.
And this is one of your applications that you
No,
wrote?
no. This is how do you call it? OEM.
Oh, okay. Got it. Oh, yes. The famous OEM board. It's running a mysterious checkout sequence where it's sending packets back to headquarters.
It's a LoRa demo, basically. If you have also another board, maybe it should detect. Oh, no, you should flash the receiver as well.
So, no, this one is not actually appearing on our peripherals list
It should.
under any TTY.
No, because it has the.
So,
You need to erase the flash and then upload TinyGo, and then.
generally, what these boards, at least that I'd found, you just needed to set some type of jumper on some of these boards anyway, in order to put it into the bootloader mode. Either that, or you need to kick it into the bootloader relatively quickly. So we could try that, right? Like if we go back to, if we unplug it, we plug it in and flash it relatively quickly. No. Tried to erase the flash. It makes me wonder if there's some different flash params for this board. I think that's what you were saying before, wasn't it? That you thought maybe the parameters, that we need to erase flash first?
Yes. Let me get the. I don't remember. Maybe I'll give you a reference here. Can you see it?
So the first thing it's doing is just trying to erase flash on that one port.
Yeah.
But I don't think that port was showing up for us. But it's ESP, tool, Pi, chip, ESP32, port, the TTY port, and then erase flash. That's what we think we want to do. And this port would be dev TTY USB 0, which, oh, now it's showing up. Maybe we were too fast. And then the command would be erase flash.
Yeah, and then.
But before we do that, let's try and flash it again now, just with regular TinyGo, because maybe we just didn't wait long enough. We're in too much of a hurry. That's a possibility.
It stopped, so maybe something it's happening. I guess you flashed it. You erased it at least. That's for sure.
I've erased it.
If I reset, can I?
Okay, no, it's still okay. No, go ahead. It timed out.
I timed out, but something happened. Let's see. Because usually once you erase this, I cannot see even the. Okay.
I'm gonna switch the switch off.
No, the
Well, that's
reset
just for the.
button. Okay, no, you did nothing. It's still.
I did nothing. Okay, we're off to a good start. All right, so let's try that. So what we were going to try, I think your suggestion was to try erasing this. So let's try that now. So it's erase underscore flash. In theory, this should basically wipe out the vendor firmware.
Correct.
But no. Did not like it. Chip, ESP32, port, That was the port.
PTY,
And
blah, blah.
erase flash. So it didn't. It did something, but did not appear to do what we expected.
No.
So let's try this.
It's done there. Yes. So. Okay. Now it's blank. Again.
No, we were not able to erase the flash yet.
It's weird because at least this should work. Let me see if we are missing the following. No. From the top of the
So we should be able to do this.
Yeah, at least this one. I'm not saying uploading, flashing, tiny go, but to erase it.
ESP32 ROM does not support function erase flash.
But this is for ESP32 based board, so this is coming straight from the generic ESP32.
Yes.
ESP32, room 32, I don't know.
But there may be some something set on this board to prevent the firmware from being overwritten.
Let's see.
But maybe that's not on one of your previous boards. Let's try swapping to one of your older boards just to see if, first of all, maybe I was too impatient in waiting for the serial port to appear.
Keep install ESP2.
It's,
Okay. Finding the serial port name.
so trying again here to see if we can.
Yeah, that's a Linux, of course.
I'm pretty confident that this should work. But one thing we can try is a cable. I've never been too shocked at the fact that it is sometimes literally nothing more than you have a USB hub in the way, and that hub is
Look at that. Look at that. Maybe we have to keep pressed.
this boot flash button. Yeah, that's kind of what I expected.
Yeah.
I mean, that's normally what is
I
the
never
case.
did it, and I think I should have remembered that, but
Okay. Well,
I did it many times and without any, from a Raspberry at least.
okay, so when we plug it in, we have to hold down that button.
While holding down the boot flash button, run ESP2 erase flash. Let's try this one. Yeah, it looks.
I let go.
It looks.
I was holding it, and then I let go. Because it didn't seem like it was actually connecting.
Erasing process begin. Sorry. Oh, what's that? Sorry again.
So I mean, I think you have the right idea there.
Wow.
Just hit the.
Yeah.
Oh, you know, too many pop-up ads.
Okay, boot flash button. If after connecting you keep seeing new dots appearing, it means it's not in flashing mode. You need to repeat all the steps described and hold it again.
Okay, so we're plugged in.
So let's not.
So we
lose
should
our
be
hope.
able
It's
to.
probably we have to match some synchronization, and maybe we need some kind of luck here.
All right, so I'm holding down the button while trying to flash. Doesn't seem like it's connecting because you can see on the screen it's still thinking. And I have to let go of the button because my thumb hurts. But no, that didn't seem to do it.
But apparently it's something quite common, so if we try again a couple of times, it may work.
Something happened different. It's sitting there. It's locked up now. Is that good or bad? It failed.
Yeah.
Okay.
Time's out.
But let's try it again. This time let's just try the erase flash. quite there. Well, it doesn't want to do it. Let's see here. I've done this on some boards that were a little bit more generic dev boards. Not quite as fancy as these. Let's try it with the default firmware that we saw before. And I believe it was saying that when you power it up, you need to hold that button down.
Okay. Good.
Assuming that's the button in question. It might be a jumper pin. I've seen that with some of these boards. I had to do that. They were ESP. They were actually ESP8266 boards, not the ESP32. But there was a jumper on the board itself that I had to flash in order to cause it to kick into the bootloader mode. Because, yeah, that still appears to be what's happening here.
Let's see on the ESP8266.
So yeah, I think we may need to go a little deeper on these particular boards in order to figure out how to flash them. So far, no luck. But we'll try again.
Okay.
But yes, this is the cutting edge, the ESP32 board. So comments from the internet, maybe ESP tool is not up to date. I believe I have the latest ESP tool, only because I had to install this fairly recently for this exact purpose. So let's see if there's a version here. Version 3.0. Now I think I'm running 2.1. That's quite a lot older. Yeah, so for sure an update to ESP tool would probably be good. So yeah, we could try that for sure. Because we definitely also want to support. Maybe the problem is that these chips are too new, and all the really old ESP32s that I have.
I have them. Well, these are more than a year old.
More than a whole year old.
Yeah. So I think
and that's ancient in internet time. Like that pair. How does that even still work?
Yeah, maybe we have to downgrade the ESP tool.
Yeah. No. Yeah. Maybe we have to downgrade. That's possible. I'm trying to remember how I actually installed it. I guess one thing to find out would be which ESP tool am I running? And ESP tool 2.1. That was installed into the bin directory. Yes, that is a very interesting question. Let's go and do a little tiny bit more research, which would be ls-la of user bin ESP tool. And yes, that's pointing to share ESP tool. That looks like your typical kind of Python install that's dropped into a mysterious subdirectory and then symlinked. How much want to bet that is in fact the case? That I have a version of ESP tool in my dev directory or something. I don't see it in here. But I may have installed it from somewhere else. But yeah, definitely an update to a newer version would probably be a very good idea. We'll do that, and we'll try this again next time.
Yeah,
because the ESP32 is actually so it's one of the boards that we really need to do more work on. Partly because like so many people are using them.
Yeah, this is quite popular and has a lot of many things integrated, and you can build an entire monitoring and actuator system just using one of those. Everything included. So it's very interesting.
Aren't you using it for some type of agricultural application?
Yes, actually I did exactly that. It's a solar powered application. You have there integrated all the circuitry. You only need to use a 3.7 Lion battery, for example, a small solar panel of like a cigarette packet, 5 by 7, and you're good to go. There are a couple of sensors connected, and I mean, considering LoRa is very low power and long range, I tested, I think it was reaching about a kilometer open air.
Wow. 1
And
kilometer open air.
yes, the collector was a Raspberry Pi connected to another one of those, ESP32, so I was just receiving from many at the same time. I have to design a small algorithm to not have any conflict for just to make sure to receive data, very basic stuff, but it was perfectly reliable. Considering, I think I tried at the same time with 10 sensors transmitting almost at the same time, and I mean, the battery lasts that way forever. I mean, I had it running on extreme conditions in Sicily, so between very cold and wet winter to hot, extremely hot summertime, and it kept sending data flawlessly. I have to say it was quite a...
And these are olive trees?
No,
Almonds.
almond trees. It
Almonds.
is, yes, almonds, yeah. Which also you need to be quite fine because almonds require not a lot of amount of water, so it should be the right thing to have. And I mean, just for monitoring. The idea was also to connect it to some actuators and hydraulic valve, which you cannot exactly power by
So like a 12-volt solenoid to turn
that's
on and
more
off the
difficult.
watering
Yeah.
system?
But usually it's more easy also to connect to the pre-existing system. You just probably have to replace the valves and put an electric one, things like that. But it was very, very fun project. Yes, absolutely.
Yeah, those,
And
those
you
are
can-
important things too,
Yeah.
though, aren't they?
Yeah, absolutely. It's a good fun. And I have to admit, because I did the same, I had the same project on Arduino. I was using NRF, the Nordic 2.5 gigahertz receiver and transmitter, which I think it was very shorter range, more difficult to implement. I mean, I did not also need this kind of frequency, so...
But
and
that's more like a serial interface that just goes over the wire, right?
Exactly.
But LoRa is a bit more of an actual protocol, right?
Well, that's not a serial, but it was hard to have a mesh network. I had to cascade each. So if I want to reach a long range, I have to communicate between modules, let's say, in a tree. So if one was failing, all the childs were failing also. So there was this kind of dependency, which I resolved with LoRa, that it's point to point. So, but in the other case, with NRF32, I had to use this strategy to have a long range. And it was not working because one fails, all the childs are also failing, and you lose connectivity for an entire branch, let's say. And
That's interesting. Well, I know that one of our contributors, actually a few of our contributors in TinyGo have been working on adding LoRa support for the new Arduino MKR 1000 board, I believe, has the LoRa chip actually on board and a built-in antenna. So I'm really looking forward to getting a chance to try some of those things out for, actually not my next talk, but my talk after that.
yeah,
First I have to do go further without wires for about Wi-Fi, and then go even further to
Yes.
talk about LoRa.
that would be perfect. I have to say that switching from that one to MicroPython was really the same project that took me quite a long time. With MicroPython was in a week, also because I had already the idea, the architecture ready, And I guess that TinyGo would be same kind of prototyping time should be very fast, I guess.
Well, I guess we'll find out.
Yeah,
Hopefully we'll get a chance to try some of these boards out and see if some of the software works on them, and
yeah,
hopefully be an interesting example of, I mean, MicroPython is really cool and it's great. We just also want to be able to do some of the same things, but faster, maybe a little bit more robust,
yeah.
maybe a little bit more failover, maybe use a little less power on these devices. The
Yeah.
less power you can use, the better, right?
Absolutely. I mean, it's key because there was. I mean, once you installed one of those in the field, you should forget about it because I mean it was in Sicily, so I will go there. I mean, no support, let's say, so it has to work. You cannot afford to have one of those failing and then all the others. I think in 10 devices I installed, I had one problem, but it was because of a loose connection at the end, a battery thing, so battery problem. But it was very reliable as well.
Wow, well, very cool. Well, thanks for dropping by, and you got to come back again
My
because I want to
pleasure.
keep working on this. I think agricultural applications that use long-range networking
Yeah,
and TinyGo are just like, I mean, what's smaller than a seed? Tiny.
yeah, absolutely. Thank you very much for the
Yeah, thanks for
opportunity.
coming by.
Thanks.
Cool. Well, that was fun. Yeah, we definitely have so many interesting projects to work on and so many important projects as well. I mean, the amount of small but independent projects that run parts of the world that are very important. It's not just about all giant agribusiness. It's all about, to me, small open source systems that let independent operators have the same kinds of technological advantages or perhaps even more. And actually, I'm in touch with quite a few people in this community, and we'll bring some of them on remotely, maybe some of them on actually in person as well, so we can talk about this important area. Because, I mean, it's all about growing together, right? Yeah. All right. So what did we get done today? We got to test out the new pull request or the existing pull request that was coming in from our collaborator Andrew Ardnew for the Teensy 4.0. So that worked great. We're ready to merge that once he rebases and is able to run against the current tests. Then we got to test out the pull request from Sago35, Takasago-san from Japan, another one of our contributors, with this awesome series of contributions lately, culminating in this extremely fast new SPI implementation for the AT SAMD 51 chips. And we got to actually test that out also on the Pi badge code, the Go badge code that was still working, amazingly, thanks to the great job of Conejo Ninja, another fantastic team member and contributor. And then we got to play around a little bit trying to get the ESP32 working with friend Lorenzo. And we'll try to work on that a bit more because that's an important platform and we definitely want to add. So with that, calling to you from northern España, from La Pipa, here in Asturias, I bid you a fantastic weekend. Let's all do some hacking on some cool open source stuff.
Computer Liste, Computer Nette, everybody that it has get flat. Computer Liste, Computer Nette, Computer Liste, Computer Nette, everybody that it has get flat. Computer Liste, Computer Nette, Computer Liste, Computer Nette, everybody that it has get flat. Computer Liste, Computer Nette.